So by taking up this work, we can get started here. The question asked us to create a first difference table, and using that, can you determine if it's linear or nonlinear? So y equals x squared plus 1. If we're creating a table of values for this one, right, it's just an xy table. And I told you that if you were confused and you really needed to solve it, you can make 3 columns instead of two, just to kind of show your work, if that helps, right? So for x, I told you to do 0, 1, 2, 3, 4. And then we plug it into our formula. Y equals 0 squared plus 1. Y equals 0 squared plus, 1 squared plus 1 here. And then y equals 2 squared plus 1, y equals 3 squared plus 1, and y equals 4 squared plus 1. So we have these here. And then on the right side is solving it. So 0 squared plus 1 is 1, 1 squared plus 1 is 2, 2 squared plus 1 is 5, 3 squared plus 1 is 10, and then 4 squared plus 1 is 17. Then once we have that down, we solve our first differences. And first differences that we talked about yesterday was to subtract the y values from bottom to top in pairs of 2. So we connect these two with the line starting with the bottom 2, and we subtract it. We do 17 bottom minus top. And so 17 minus 10 will give us 7. The next one over, 10 minus 5 is going to be our next one. It's going to give us 5. And then 5 minus 2 is the next one, which gives us 3. And the last one here is 2 minus 1, which gives us 1. And so within our first difference column here, right, we can see none of the first differences are the same. So therefore, nonlinear, right? The only time this is the same is if it is linear, right? So that's important to remember, okay? The next one here we'll quickly go through. Just going to do a table of 2 because this one's a little bit easier because it's just x plus 1. So we're just going to do x and y. What you should have gotten for your final values here is 1, 2, 3, 4, and 5. And solving it out, you should have gotten 1, 1, 1, and 1 as your first differences. So therefore, since the first differences are the same, it is linear. Okay. And the last one will work in more detail because it is something you haven't seen before. So let's draw our triple table here just to make sure we're all on the right page for this one. So x is still going to be 0 to 4. That doesn't change. Our x is going to be something different. So it's now an exponent, right? Normally we have it as a regular number, but now it's an exponent, part of a power. And then, so filling this out in the exponents, we get something like this. Excuse me, I need water. I'm getting the hiccups. Okay. So 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. And 2 to the power of 4 is 16. Then when we solve this out, and doing it, 16 minus 8 goes first. We go bottom to top. That's going to be 8. And then we do 8 minus 4, 4 minus 2, and then 2 minus 1. So there are the first differences here. And are they the same? No, none of the first differences are the same at all, right? They either all have to be the same or they don't. And so therefore this is nonlinear. And most people got it yesterday, but this is just to double check your work, making sure that you got it right overall in the first place. So if you got something wrong, maybe you got the answer right, but you might have done the table wrong. Just double check your numbers. Make sure you are plugging it in correctly because you don't want to mess this up on your test, because having the correct table of values is going to make sure your graph is right too. So make sure you practice that here. Okay. We'll talk about what's going to be on the test. Well, everything pretty much on the review sheet is on the test. And the test is short. This test is short. We have multiple choice and then just 2 pages of problems, and that's it. Very short. I'm trying not to make it too difficult because I want to separate it into 2 different ones. Because Unit 3 is the more is going to be more deep and focused. All right. So if we don't have any questions on this, we are going to move on to the next one here. And this is 2.4. So if you haven't finished off yet, okay, if you have not finished, or if you haven't printed this off yet, please go get it printed. I'll wait around 2-3 minutes. Once you're ready, type a G in the chat. We're just waiting on what, 3 more people? Just 3 more people, and then we can get started here. All right, just want to double check here. We are missing, looks like Sina. Are you good to go, Sina?
What's up?
Are you good to go? Do you have this page ready?
Yeah, I have a paper to write.
Okay. So that means we're double checking with Milana. You good to go? All right, Milana's good to go. And I think that would be everyone. Okay. Let's get this started here then. So 2.4, so this is our last new lesson before your actual test. So let's get this through, and then let's review for our test, or start our review. And then we'll continue the review tomorrow morning before the test actually starts, and then you'll have your test in the second half of the class. So let's review with a problem here. So Homer recently joined this all-night gym in Springfield. The graph below shows the relationship between the cost and the number of months he visited the gym. So here's our graph with the number of months and the cost with how much he went every month, or how long he was there. So let's examine the graph. Let's answer these questions. Number one, is this graph, what type of variation does the graph represent? Is this direct or partial? Anyone can type it in the chat. Good, Gerald and Mercel typing at the same time. Very good. This is most definitely partial. It is not starting at 0, 0. There is an initial value, so it's 100% partial. Second, what is the initial charge of this gym membership? What's the initial charge? Yeah. Gerald writing 100, absolutely. It's the starting charge. So even though Homer doesn't go to the gym, right, at 0 months, he still has to pay $100, right? So that's the initial charge. He's always going to have to pay $100 no matter what. And so because he's always going to have to pay $100 no matter what, that's going to be the initial charge. There's other names for it, right? Initial value, fixed fee, flat fee, that kind of stuff. That's what it's referring to. Then it says find 2 points on the graph and calculate the slope. So I'm going to give you guys 3 minutes to do so. Okay? It could be any point. So when you're looking for points on a line, right? You're looking for where does it hit the corner of the square on the grid, right? So you could use in red. Let's do it in red. You can do right here, 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 or here, right? You have one of these five, any of these 5 points, you pick 2 of them because they all touch the corner of a square. So feel free to pick any of those 2, and can you calculate the slope for me? And we'll take it up in around 3 minutes. let's take this up now. Let's see what we have here. Okay. Um, okay. So, calculating the slope, you can pick any two graphs here or any 2 points here. So let's say I pick this one and this one here. Depending on how you did it, it doesn't really matter. You should still get the same result. So if you did the rise over run method, which was to create, if you have a grid and a graph, you can create a triangle. You can calculate slope that way, or you can use the slope equation. So it really depends on how you want to do it. If you use the slope equation, you would say, oh, this point is 2 comma 150, and that would mean x1 is 2 and y1 is 150. And the second point would be 6 comma, let's see here, 6 comma 250. And so x2 would be 6 and y2 would be 250. Once you have that in, you can solve it here. 250 minus 150 divided by 6 minus 2. And solving it, we get 100 divided by 4, which will give us 25. Okay. So that would be your slope. You should have gotten 25. And it's the same thing as if you did rise over run. So if in red, if we're doing rise over run, we count the squares. Each square is 1 in the horizontal direction. So 1, 2, 3, 4. That's going to be, oops, that's a giant. That's too thick. It's going to be 4. So that'll be 4 here. And here vertically, each square is 50. So it's 2 squares, so it's 100. And so if we do slope as rise over run, you would just directly put in 100 over 4, which will still give you 25. So regardless of whether you did the triangle method using the graph or you did the slope formula, you should get the exact same answer, right? Then it asks us, how would you describe the rate of change? So the rate of change is the explanation of the slope. It's the explanation of the slope in terms of the question here. So what does the question mean here? So describing rate of change, what does the 25 mean? What does the 25 represent? Does anyone have an answer? Cost and number of month is what Elias said. You're really close. It's not and. Yes, Gerald has it. Cost per month. So Elliot, you had it. You just used the wrong word. So I know what you meant. Yes, it is cost per month. So this would be $25 per month. Perfect. And you guys are getting it, right? Because we're saying that rise is Y and run is X. So we're taking the units, right, and putting them at the end. Now that makes sense. The gym is charging $25 per month. We have units to represent it, and that's what Elia and Gerald were saying. It's the cost per month. It's dollars per month. And so that's very important. Can you get the units? And you should, right? Because you have your graph, you have exactly what the X and Y variables are. It's only one step further from that. Okay. So continuing on here, write an equation to represent the relationship between the cost and the number of months Homer visited the gym. So we already said in question A, okay, this is important, it's partial. We said it's partial. And for partial equations, we know that the equation is of the form mx plus b. So now let's fill in the blank. We know what m is. We know what the slope is. So we can immediately already write out y equals 25x. And what is b? What is b?
The initial amount.
Yeah, the initial amount, which is the plus 100. Perfect. And so that's this thing right here, and that's going to come down right here. Okay? So the initial amount, the y value, like Roe and Mersel said, is 100. And so that's what we're going for here. And there's our equation, and this would be a full check. Perfect. So remember, the rate of change is represented by the slope graphically, and we use y equals mx plus b for partial variations. We use y equals mx for direct variations, right? So those are the two equations that you should have ready and good to go. Now, continuing on here. So once again, the m is the slope slash rate of change. Well, this is the y-intercept slash initial value. Let's write that I again. Initial value slash, so y-intercept, initial value, as well as like you can call this fixed cost, right? So there's a lot of different names for the b value, but that's essentially what we're working with here. Okay. So we can immediately, if I give you the equation, you should be able to get the slope and the y-intercept. I'm going to randomly pick names to answer these questions. I'm going to give you 2-3 minutes to just write down what is the slope, what is the y-intercept for each question. I'll do the first one for you. So -2, that's in the m position. So that's -2 is the slope. And -5 is in the b position. So that's the y-intercept. Very simple and straightforward. You just look at the equation, you compare it to this one, right? This is what you're comparing it to, y equals mx plus b. And so when you compare those two, what do you have? So give this a shot, and then we'll take it up in around 2 minutes. Shouldn't be that long. 2 minutes is plenty of time. Okay, let's take it up. Let's pick some innocent volunteers to be voluntold. I think yesterday we didn't let Suyong go during the first initial pick. So Suyong, you're gonna go first. Suyong, for the second equation there, what is the slope and what is the y-intercept? Feel free to type it out or say it. It's up to you. The y-intercept is positive 2 is correct. The slope is not 0. It's 1. And so remember, whenever there's no number in the front, it's going to be a 1. Because if it was 0 times x, the x would be gone. So the y-intercept is correct. Just wanted to fix the slope here. It's 1. Second one, let's pick Milana. Milana, you were not here. So let's make you do this next one. What is the slope and y-intercept for the next equation? Eight, and I think that's 2 over 5. I think the 1 is a typo, maybe. But yes, it is 2 over 5. Good. So it's 2 over 5. That's the number in front of x. And the y-intercept is 8. Very good. Next one, let's pick Roe. Your name came up on my screen. So Roe, what is the slope and y-intercept for the next one? Two and 1? Close. Not 1. This one is 0. So this time, the b value is just not there. It's gone. It doesn't exist. And so this one is 0. Okay? So this one's 0. So 2 is right. The slope is 2. The number is not there at the end, so it's 0. And the last one. Let's pick Mersel. Mersel, what is the slope and y-intercept for this last one here?
I feel like 6 is the slope itself. I don't know, I could be wrong.
So what's the y-intercept then?
I don't know, is it like, could 6 be the y-intercept just like sitting on the line, like 0 and 6? But then there's no
So
x, there's no slope.
you're saying 0 and
Could it
6
just
like
be
this?
a straight line? Yeah.
And the answer is yes, it is 0 and 6. It is a flat horizontal line because we learned it from previously that a slope of 0 is a flat line, right? It's a straight horizontal line going across at the y equals 6 value. So this is absolutely correct. And the reason why, so looking at the main differences, like comparing this one and this one here, we set the slope as 1 here because the coefficient is 1. But in the second one here, in this one, the x isn't even there in the first place, and that's what makes the difference, right? And so this is why I had Suyong and Mersel do these two. Personally, because I wanted to show and compare, because it's not easy problems when you first look at it. It's not supposed to be easy, right? Because you are identifying it, and there may be tricky ones like this. So these are concepts that do happen, and I thought that they could tackle it, and so I gave them those two questions in particular. So hopefully now you can see the difference between the 1 and the 0. Okay? So that's the thing that we're going for here. So let's move on into the next one here. Example. We have 4 more examples, but this time it's asking us to identify the slope and then the y-intercept and then create the equation. Okay? So the way you find slope is up to you. I have given you the graph for all of these. However, if you want to pick 2 points and use the slope formula, you can definitely do that. So the first one I'll do, okay, for you guys. So if I pick 2 points, the first 2 points I saw from this are these 2 points here. So these 2 points I quickly saw and I said, oh, okay, I'm going to use that to solve my slope. I'm going to use my rise over run method. Just like that. And so since each square is 1, both vertically and horizontally, this is 3 squares to the right, and this is 2 squares up. So it's going to be 2 over 3. There's my slope. Then for my y-intercept, I look at where is the y-axis and where does the line touch the y-axis? And that would be right here. And so the line touches the y-axis at -5, so the b value would be -5. We now have enough information to write our equation, so we can write y is equal to 2 over 3x minus 5, and this would be the final equation for this question. So there's our line equation of the line. So that's essentially how you're doing it. Once again, I use the rise over run method, but some of you may want to practice a slope formula. That is up to you, right? But I will give you 5 minutes to solve these questions. I will pick 3 more people, right, that I have not chosen yet. So Mersel, Roe, Suyang, and Milana will not answer the next 4 because they did the first 4. So everyone else, you better be focusing because I may pick on you next. So I'll give you 5 minutes and then we'll take it up at around 9:45.
Sir.
Yes, you have a question?
What is this unit called?
Linear relations. It's on Google Classroom. It's written there.
Okay, so because when we have a test, you said.
Uh-huh. The test is tomorrow.
Oh, okay. Because I'm gonna review for it, and yeah.
Everyone has class tomorrow. You have class every day with me. Day 3 and 4 now, everyone comes to class at 9 a.m. So normally it's supposed to start at 8:45. I'm already starting later at 9 a.m. Everyone comes to class on day 3 and day 4 at 9 a.m. Both classes are now combined into one until for the duration of the online lessons. And then day 1s and 2s, everyone comes to class for 2 p.m. So hopefully that clarifies things. Yes, you have class tomorrow morning. Okay. We've waited long enough. It is 9:46. Let's start with the first one. Elia. For this one here, for question B, what is the equation that you got? Just tell me, like, y equals what? You can just type the equation and we'll check it. Oh, you want to do the second? Sure. Then let's go James. James, have you solved question B? What is the equation of this line?
I'm still trying to figure that out.
Okay. Gerald? Question B. The equation for question B. Y equals, so you have y equals -4 over 2 plus 2. You're missing your x, which would go here, right? But it's not plus 2. So we're going to quickly fix this. It's not a plus 2. You should have gotten -4 over 2x plus 3 because this is 3. So where it touches the y-axis is 3 here. The slope is right, but remember, if you can reduce the slope or you can simplify it, please do. You should have gotten actually just -2x plus 3 because -4 divided by 2 is -2. So that's the simplified version of the slope. So your slope was correct. Your y-intercept was off by 1. So very well done. Now, if you guys are ever confused on like, oh, how do I pick points? The y-intercept is always helpful that if it's a point, because then you can just pick, boom, you have your 2, you can draw your line, or you can do your slope formula, whatever it is, and you should get your right answer. Okay? All right. Elia, you said you wanted to do C. So, Elia, what did you get for question C? What is the equation of the line? Y equals? So you wrote -6. So that is not correct. And the reason for that is because the y-intercept is over here. So the y-intercept here, immediately we can see that the b value is actually 4. So you wrote -3, so I'm a little confused where you got the -3 there. But the b value is 4. Okay, so the first thing you should be looking for here when you're looking for the equation is find the y-intercept. It's one of the easier things to do because you're looking for the y-axis and you need to pick your point there. Then you can pick any other point. Now the slope is not negative. This is a positive slope. It's increasing, right? So it's an increasing line. It's positive. But you said it's 6/8, right? Which is true. That is correct. It is 6/8. So your slope is correct. However, you need to reduce that. So you wrote 6/8x should be plus 4, but we need to reduce that, and it should be 3/4x plus 4. And that would be the correct final equation. So it's not negative, it's positive. It's not going down, it's going up. So your slope was correct. So you were also right on the slope. You just got the y-intercept incorrectly. Okay? So hopefully that makes sense there. And the last one for question D, Kuzli. You're not escaping from me, friend. Kuzli, what is question D? What is the equation for question D? So remember your b value, let's talk through this one now. Let's talk through this one. So once again, if you're given a graph, rise over run is what you want. Find the y-intercept first. You have the y and x axis. Look at the y-axis. Look at where the line touches the y-axis. That's this point right here. What value is that? Oh, that's 2. So immediately we can write, oh, b equals 2. That's the y-intercept. Then, because that is a point, okay, we can just find one other point of the line. And to find that, once again, we're looking for the corner of a square. So I found this one right here. Oh, that's a corner of a square. We can then draw our triangle like this. Oh, actually, sorry. Run first, always. Run.
So how you
Then
found the second one?
you're looking for the corner of a square. You see the grid squares? You're looking for where the line touches a corner of a grid square.
Oh, I see. Okay.
Yeah. So then run first. Run is you always start from the leftmost point. You count the squares going towards the right. So for us, it's 2 because each square is 1. Then we go down and it's going down by 3. So it's -3. So my slope would be -3 over 2. So my final equation, I put it all together. And there's my final equation for the last one here. Okay. Y equals mx plus b. We just replace m and b with the values that we found. And voila, there's our final answer. Okay. So once again, make sure you get the practice with this. It is a new lesson, of course, right? So let's continue on here because we got a couple more questions to go through. Now let's graph it. So what if I give you the slope-intercept form and I ask you to graph it? Is this coming on the test? Yes. So let's state the y-intercept. What is the y-intercept here for this question? Well, it's b equals -1. Very good. B equals -1, right? That's the y-intercept at the end there. And so that's step 1. Identify the y-intercept. Step 2, plot it. So y-intercept, we look at the y-axis. Oh, it's right here. I'm going to do it in red. Boom. There's my y-intercept. I plotted my y-intercept. Done. Okay? Next, it asks us to find the slope or state the slope. The slope is going to be 2 over 3. And Mercel said it in the chat. And that's the value in front of x. So the slope is 2 over 3. And now we're going to use it to find our next point on the graph. So if we count up, we go 1, 2, 1, 2, 3. So if I use kind of like my black pen here, I go up 2 squares, right 3 squares, and there's my next point. Then I do it again, up 2 squares, right 3 squares, and there's my next point. Once you have drawn 2 more points, once you have drawn 2 more points, you can now connect with a line going across. And I'm going to try to make this line bigger. Just like that. And there we have it. And so that's going to be the line that we're drawing. So using the slope, right, we count squares. Rise is up or down, and the run is always towards the right. Okay, so there's our example. Would anyone like me to go over the example one more time? All right, so we got a yes. We're going to go over it. As long as there's one person that says yes, we're going to go over it one more time. So the first one, step 1, the y-intercept, once again, is from here, right? Because we have to remember when we look at the equation, we're looking at y equals mx plus b. So we know that the y-intercept is the b value. That's -1. In our question here, that's -1. Then step 2 is to plot that point on the graph. So -1, we find it on the y-axis here, and that's going to be this point right there. That's going to be -1. Our third step is to look at the equation again and find the slope. And so the m is 2 over 3. And this, remember, is rise over run. So our rise is +2, which means we go up by 2. The run is +3, which means we go to the right by 3. So we're going to go up 2 and then right 3. Whoops. Like that. And we're going to draw our point there. And we do it one more time because we want at least 3 points on our graph. and we draw the next point there. Then we can connect it all with a straight line, just like that. And we can extend that line, and voila, there's our line of our graph. Okay, so that's the line for the equation. Okay, so now it is your turn. I'm going to leave this one on the screen for you, but follow these exact same 4 steps and graph 5/4x minus 2. Okay, so please graph this. I will give you 5 minutes to do so, and then we will take it up. Okay, it's been 5 minutes. Let's check your work here. I'm going to go through it here. So first step, stating the y-intercept is always first. So b is equal to -2 in our situation here. We're going to plot that onto our graph. That's step 2 on the y-axis. So y-axis -2, we plot that down. Step 3 is to state our slope, and our slope here is 5/4. And then we're going to use that on our graph. So remember, this is rise over run. So the rise is positive, so we're going up by 5, and we always go to the right for the run. So we're going to go 1, 2, 3, 4, 5 up, and then 1, 2, 3, 4 across. And we're going to land right here for our second point. And our third point, we're going to do the same thing, go up by 5. So 1, 2, 3, 4, 5 up here. And right by 4, ending us here for our next point. And if you have a ruler, you can connect them with a nice, beautiful line. Whoops. You can connect it with a nice, beautiful line, which I'm going to do right here. Boom. There's our nice, beautiful line. I'm going to extend that and make that a little bit thicker. And there we have it. So that should be what your graph looks like. If you got that, fantastic. If you did not, try practicing on the next few questions that you're going to get in a little bit. Okay? So I'm going to leave that on the screen for around 30 seconds for anyone that needs the copy, and then we're going to keep going. All right. Moving on here, we're going to do one more question, and then we're going to do the asynchronous portion where I give you around 15-20 minutes to do the practice questions, and then we move on. So here, example, identify the slope and vertical intercept of the following linear relation and explain what they mean in this context. So this is kind of like a communication problem on a test. So here, the graph title is height of a tomato plant after planting. We have the height and we have the time for the x-axis. So the first thing we want to do is we want to identify the y-intercept. So the y-intercept here is 6, right? The y-intercept here is 6, and the slope, if we pick our second point to be here and we draw our graph here, on our graph, we try to do the rise over run here. The run here is 2, and the rise here, although it's 4 squares, it's going up by 2 every square, so that's actually 8, right? 2, 4, 6, 8. So it goes up by 8, so that's going to be 8/2. So my slope is actually just 4. Now, what does this mean in terms of this context? Well, the initial height would be 6. So this is the starting height of plant. And hopefully you guys can understand how I got that. Because if the B is the initial value, that's at time equals 0 seconds. 0 weeks. So if nothing has changed and it's already at 6 centimeters, that must be the starting height of the plant. For the slope, however, we can just take the units. We have the 2 units here. This is technically 4 centimeters per week. So can someone type a sentence for me that explains what this is? So we found the rate of change. So what does this represent? Can someone type a sentence for me in the chat, please? Growth of the plant per week, absolutely. So this is how much plant grows every week. Perfect. Well done. So that's what the slope represents. So you should be able to also understand, if I give you a graph or a word problem, you should be able to tell me what the slope and the y-intercept means in the context of the word problem. And so that's your goal. So from here, from now until 10:30, you have all that time to work on the following questions. You'll notice there's like 3 pages of questions. They're just typed out really big. So give these ones a shot over the next 20 minutes, and then we're going to move on to our review session for our test. Can I scroll up? Yeah, absolutely. I'll leave it here. So please try the rest of the questions over the next 20 minutes. No one leaves class, of course. This is the asynchronous portion. If you have questions, type it in the chat, and I'll try to answer as soon as possible. But I'm also going to have to get some water and use the washroom and stuff and take a break. So take your time with it. Do you mean last one as in like the very bottom? Like this one? Like the very, very bottom? Sure, I can do the last one. If you have any other questions that you want me to take up in particular once we hit 10:30, just let me know. I paused sharing for a little bit. Sorry about that. So another 4 minutes left, and then we'll continue on. All right, so I got a request to do the very last question or take up the very last question. Does anyone else have any other questions that they want me to take up in particular? I'm not going to do all. Pick specific ones that you want me to do. Which one? There's a lot of examples. You got to be specific. There's like a bunch of examples. Okay, I can go through that. So first off, everyone knows how to get the y-intercept and the slope, right? You finding the y-intercept should not be too difficult. It's the so it's where the line touches the y-axis, which is right here. Okay, and that's 6. We know that's the starting height of the plant because, well, that's at 0 weeks. The main thing is that at 0 weeks, that's where it starts. The slope, however, we needed a second point, so we plotted our second point right there. We drew our triangle to do rise over run. We found our run to be 2, and our rise is 8 because each square is 2 for the scale. So then we do 8 over 2 for rise over run, and we got 4. To get the units, it's rise over run, so y over x, which is centimeters over weeks. So it's 4 centimeters per week. And then that tells us how much the plant grows every week. So that's what the units represent, centimeters per week. So there's that one there. It looks like no one else really had any other questions in particular because I'm not going to go through all of them. I will go through one question from the first part here. Graphing the following lines. Let's zoom in just a little bit so that we have a little more space to work with. Once again, the y-intercept is 3, right? So b equals 3. We're going to plot that first. That's going to be the first point you plot. So b equals 3. The y-intercept is 3. Then we take our slope. Our slope in this case is now negative 1 over 2. The negative is in front. We're just going to put that always on the top number to make our life easier. And so that means we are going down by 1 and right by 2. And there's our second point. We do that one more time, go down by 1 and right by 2. And that's going to give us our third point here. And there's our line. We can connect that with a beautiful straight line, like such. And we're done with that question. That's a little too thick, but that's okay. Maybe something like that. Perfect. So there's our straight line. That's how you're going to be drawing your...
Excuse me, can you say the moves again?
What do you mean?
The moves, because you went to 3 and after that you came to 2.
Yes, it's rise over run. We're using the slope. You go down by 1, right by 2. You start at 3 because the y-intercept is 3.
Yeah, so we have just 2 moves.
Yes, you go down by 1 and right by 2.
Oh, I got it right now. Thank you.
Okay, so you're using the same process for all of them. remember, it's very important that you identify what your y-intercept is, because that's always going to be your first point, right? It really helps to understand that what your y-intercept is. This one here, the slope is 0, which means it's a flat line. So you can kind of just draw a flat line across, right? And this one here, the slope is 2, or 2 over 1. All whole numbers are over 1, so you can graph using that as well. Okay. So let's go to the question Elia mentioned, which was the last one at the very bottom here. This one was probably confusing because people weren't sure. You're given the point here. You're not used to going negative, but it's the same idea. We start with the y-intercept. So let's write that y-intercept down, shall we? I don't know why it's doing that again. That's so annoying. Okay. So we're just going to write the y-intercept down here, right? That's that. Okay. So b equals -3 is going to be our y-intercept here. Our rise, run, and our slope. So first we need to find another point on our graph. So if this is a point on our graph, the first one I found was here. Okay. So there's my second point that I'm going to use. I can then draw my triangle, which is our rise over run. So let's add a pen. Let's put it as orange, and I'm going to draw it like this. Boom, there's our triangle that I'm going to be working with. And my run is 2. So I'm just going to write it here. My run is 2. My rise is 1, 2, 3, 4, 5, 6. So -6. So my slope is rise over run, which is -6 over 2, which we simplify to -3. So then we can write our equation, which is y equals -3x minus 3. And there's our final equation for the line there. Okay. Any other questions you guys want me to take up for this one? Otherwise, we're going to move into our review now. No problem. All right. Going once, going twice. All right, let's move on. The final thing, it's already uploaded here, which is our test review. Whoopsies. I opened the wrong one. That's going to be a little bit of an issue. Let's open the correct one here. All right. So this is our unit review for linear relations. I'm actually not going to fill in most of these, but I'm just going to be talking about the concepts that are going to be on the test. So it's a lot. It's 8 pages because it goes through all of the concepts. We're not filling anything in. We're actually going to take today's time. Like you guys already know how I do things. I give you one the day before to try the review package yourself. And tomorrow we're going to be taking most of the review package. And whoever is drawing through the annotate, you need to stop. Stop drawing on the screen with the annotate button, please. Thank you. So, let's go over some concepts. So first, reviewing linear relations here. You can represent a linear relation in 4 different ways. Am I going to post the completed work on the
already in the Google Classroom, right?
This is already on Google Classroom, yes.
Alright.
You guys can actually go look at it on Google Classroom, but you don't have to go print it right now. Let's look at it from here first. I'm just going to talk about the concepts, and then for the rest of the class period, I'll be here if you have any questions, and you can answer them while you're here. If you want to go, you can go off and answer it, but we will be taking it all up tomorrow before your test. Okay? So linear relations can be represented in 4 different ways. You have words, for example, a large pizza costs $8 plus 50 cents for each topping. You should be able to represent this in a table of values, in a graph, and as an equation. So you should be able to do all of these. If I give you a word, can you represent it in all the other different ways? Then we talked about direct and partial variation. Here's the very quick rundown of it. We know that direct variation starts and passes through the origin, and a partial variation does not pass through the origin. And the equations that we use, it's pretty much the same. The only reason why the direct variation is y equals mx is because the y-intercept is 0. Like the b value is 0, so it's just y equals mx, compared to the partial, which is y equals mx plus b. So the questions, of course, here talk about identifying direct or partial, stating independent dependent variables, and writing an equation. There's a lot of questions on that. Remember, you should know how to graph. So in question 4, as you can see on the screen here, you should be able to know how to graph. So can you give me your graph title, your axis titles, a proper scale? Can you graph it correctly? So on and so forth. Okay. Remember, graphing is a big part of my tests. And I told you that before. It's like 7 marks, easy, right? Table of values is 1 mark. All the titles is 3 marks. The 2 scales are 1 mark each, and then the graph itself is 1 mark. That's 7 marks. You don't want to lose such easy marks, right? Especially if you get the axis titles wrong, that sucks, because you know that was something that's easily you can get the mark for, right? So you don't want to get the axis titles wrong. Make sure they're in the correct spots. Make sure you write them down. We then talked about slope, right? We have our 2 equations, rise over run, as well as m is equal to y2 minus y1 over x2 minus x1. These are all equations that I will give you on the test that you can use. So please keep that in mind here. And you need to be able to find slope using these 2 formulas. Sometimes I give you the slope or the grid. Sometimes I don't. I give you 2 points. It is up to you to figure out which method to use. And so you'll see a whole bunch of examples here and some questions, as well as the 2 special cases where for horizontal lines the slope is 0, and for vertical lines we call it as the slope is undefined. Lastly, you should be able to write the equation for the linear relationship. You should be able to define it in terms of the relationship. And yesterday's lesson, we talked about first differences. So can you calculate first differences if I give you a chart? Can you tell me if it's linear or nonlinear by showing me the first differences? And there's going to be 2 kind of word problems at the end. Can you describe or explain to me and compare different things, right? Can you explain to me what the rate of change means in terms of the question? Can you explain to me what the y-intercept means? Can you explain to me which person is better, or which company is better, or whatever it may be, right? So you should be able to also do this, and this would be the last part. So that's the quick